Welcome to the deep dive. We're surrounded by just tons of information, right? And AI is becoming this key tool for sorting through it all. But do you ever wonder how it actually handles the really, really big tasks? Today we're going to dig into something fundamental. The difference between multi-agent and single-agent AI systems. Understanding this is, well, it's pretty crucial for grasping how AI scales up. Okay, let's get into it.
Exactly. And this isn't just, a technical footnote, how these systems are designed. It shapes everything. Efficiency, how reliable they are, even the kinds of problems AI can actually solve for you. It's really about the architecture fundamentally changing what's possible. Okay, so let's start with multi-agent systems. The easiest way to think about them is like a team. A team of specialized AIs all working together. Their strengths are pretty obvious in certain areas. They're really good for tasks you can break apart and do in parallel.
Like what kind of test?
Well, think large-scale research, maybe gathering huge amounts of data really quickly. They boost speed because lots of smaller tasks run at the same time. And there's a really interesting point about robustness.
Right. If one part fails.
Exactly. If a sub-agent, one of the team members, sort of goes offline, the orchestrator, that's the AI coordinating everything, it can just spin up a new one. So the whole system doesn't just crash.
That makes it pretty resilient then.
Very. And they can even mix and match AI models for efficiency, maybe a powerful one coordinating smaller, faster ones. And crucially, they help get around a big bottleneck: context windows.
The memory limit, basically.
Yeah, essentially. By splitting tasks, each agent only needs to remember its small piece. Then they combine the results later. It's less like one giant brain, more like a coordinated network.
Okay, that parallel approach sounds super efficient, like a production line for data.
Right.
But coordinating all that feels like it could get messy. Where does it start to break down? What's the catch?
You're right on it. They're powerful, but yeah, there are big drawbacks. The main one, tokens. They use way, way more tokens.
Tokens being the sort of computational cost, right? Like the currency AI uses.
Precisely. More agents running means burning through vastly more tokens, so it gets expensive. Fast.
Right. Okay. So cost is a big factor. And I guess they're not great if the tasks rely on each other. Like if step 2 needs to know exactly what happened in step 1.
That's the other side of it, yes.
Yeah.
If tasks need that shared evolving context, multi-agent isn't ideal. And honestly, the coordination right now, it can be fragile.
Fragile how?
Well, the agents might not align perfectly. They might not pass context correctly between them. You can end up with inconsistent results, maybe even chaotic ones sometimes.
Like an orchestra where everyone's playing slightly different music?
Yeah, something like that. You might get something interesting, but maybe not what the conductor intended.
Okay, let's pivot then. What about the other side? Single agent systems. This is more like one AI, working through a task step by step.
Exactly. One focused AI handling the whole thing sequentially.
And its strengths would be?
Well, they really shine when context is king, when decisions need to be remembered and built upon throughout the whole process.
Like coding or writing something long.
Perfect examples. Coding a complex app, writing a novel. Anything where coherence and that chain of logic are vital. They tend to be more reliable for completing a task end to end if that task isn't easily split up. The context just flows linearly, which cuts down on miscommunication.
But that linear flow must have a downside too, especially for huge tasks.
It does. That's their main limitation. For really big, complex jobs, a single agent can just run out of memory. It hits its context window limit.
Context overflow.
Right. It just can't hold all the necessary information in its active mind at once. Imagine writing that novel, but you can only remember the last page or two.
You'd lose the plot pretty fast.
You'd definitely risk it. Now, there are workarounds like context compression, basically summarizing, but they're hard to do well without losing vital details or, worse, introducing errors.
So it's a real balancing act. You've got these two fundamental approaches. How do you actually choose? What's the rule of thumb?
Well, the core idea, if you boil it down, is this. Go multi-agent for speed on tasks you can easily parallelize, where the pieces are pretty independent. But if that continuous thread of context is absolutely critical, if the steps really depend on each other, a single agent or sequential process is probably safer, even if it's slower.
And that context overflow is the big hurdle for single agents on massive tasks.
It really is. Multi-agent helps with that, but you pay for it in cost and coordination headaches that potentially chaotic orchestra again.
So there's no perfect answer, is there?
Not right now. It always comes down to the specific job, what you need, the data involved, and honestly, what the tech can handle today. It's all about trade-offs. So maybe something for you listening to think about how this choice, multi-agent versus single agent, isn't just technical. It really defines what kinds of problems we can even try to solve with AI. Knowing these pros and cons, these strengths and weaknesses, how does that change how you look at AI's capabilities? And maybe ask yourself, for your biggest, most complex data challenge, which system would you bet on?